Good evening, everybody. So let's see how all these new technologies that exist around us can be used to build an ecosystem that could help science, that could help business, and that could help citizens. And let's start with the Earth. You know our Earth is not doing so well. Let's go back in the 80s. Scientists discovered there were a big hole in the ozone layer, and this was not very good. So they say, okay, we have to do something. We really have to do something. Very fast, ESA built a satellite and an instrument that could be sent right away to measure what was happening over there. We also discovered what was the ozone killer. It was this CFC gas using for the cooling system. And scientists start to work. Politics start to work and say, okay, we have to dismiss this product. We don't use it anymore. It's forbidden. And let's see if this is going to work. And yes, it works. The hole is closing. So when everybody works together, when everybody is willing to work together, we make really good things. So on this idea in 2005, there were a group for Earth observation that was established. It's a big group based more or less on the same United Nations style. And they start to see how can we build a system of systems that would allow to use all what is being used currently but in isolation, so that we can put all these instruments, all this data together and make progress. Because if you put everything together, then you have a better insight of what is happening. They have a lot of priorities of things they want to look at. One of them being the monitoring of geohazard. You know, volcano eruption, earthquake, landslide. Those are more or less natural, some human-induced. And this was because of the 2000 World Summit on Sustainable Development, where they say, okay, we have to do something. The G8 said we have to do something. So let's work together. After this was created, they had a plan of action. And looking at the geohazard, it happened in Frascati, where I'm working, in Italy, south of Rome. A very good wine there. And those scientists were all sitting there and saying, what could we do with this? And they went out in these nice places that we have, take a good glass of wine and discuss. And at the end, the Frascati Declaration came out. And they say, okay, we, scientists of the world, are going to work on trying to do something to understand better earthquake and volcanoes and help science, help people, help. So everybody start to dump their data. We have in ESA an open and free data policy. So they dump the data, but not only the satellite data, in situ data, whatever data scientists can come on, all kinds of scientists. And what we built, it was back in 2008, 2009. Big data does not really exist at the time. Let's say it was just emerging. So they call it supersite. Supersite meaning, okay, this is a place where we are going to collect as many information as possible so that we can try to find something. So this supersite started, as I said, scientists start to put data, but not only data. They put also tools, piece of software that allow to know, understand, transform the data into information, do something with this data. And then, okay, the world is done so that there is a lot of earthquake. We had the L'Aquila earthquake. We had, and this was in 2009. Then there were Haiti earthquake in 2010, and then the big Japan earthquake in 2011. And this demonstrate, this supersite approach demonstrate to be extremely useful because we understood better before, during, and after what really happened. But we also help, although remaining very scientific based, we also help the rescue team because they could understand where were the safest place to go and to start to help the people over there. So this was very useful. for citizens, for science, and eventually for business, because at the end, some people were also able to use some of these things to create some business from it. So we extend this idea and say, okay, this is interesting, but we could do more. We could not only look at Earth observation, but we could mix with other science, and there is a lot of science around there. So we discussed with CERN. You may know CERN, I suppose. We discussed with EMBL, not very far from here. We discussed with ECMWF, it's the weather forecast for Europe. I mean, all these big European international intergovernmental agencies. And we all have the same approach. We have a lot of data. We have a lot of scientists on, yes, why don't we try to build an ecosystem that will allow data to be better used and the scientists to have easy access to this data. So this is where we started to have this idea of building an ecosystem for science, where we would have data, tool, scientist, computing, of course, because you need computing, and, very important, the management of the intellectual property rights, okay? This is very important. And multi-domain, so biology, Earth observation, weather, physics, you name it, whatever. And we say, okay, we want to do this ecosystem, and we want some very important core value and principle to be taken into account. It has to be open. It has to be competitive, okay? If you are good, you remain on the ecosystem. If you are bad, you will be kicked out, okay? It has to be fair, okay? We wanted that the governance remain science-driven, okay? But it still needs to be very attractive for the private sector. Everybody has to earn something coming on the marketplace, coming on this ecosystem. And as I said, we needed to have, it's important that people remain in control of what we call the IPRs, which is the intellectual property rights, easier to pronounce, IPR. And this means that whatever you have, you put it on the ecosystem, you put it on the marketplace, but you put it under your own conditions, okay? This means that if you want to give it for free, you give it for free. If you want to make people pay for it, you make people pay for it. But you want to have traceability on who is using your IPRs, how they are using it, if they are reusing it for something else. So this is very important. It's not that you just give away things and then somebody does what he wants with it. So this is the value and principle. The players, of course, what we call the big data factories, CERN, ESA with the satellite, EMBL with this DNA data set. There are so many of them. So all these people, industry, SMEs, national and European policymakers, okay, those that decide, like we said for the ozone earlier, those that decide, okay, we have to stop the CFC. These are the policymakers, okay? And scientists, of course, that will be the first, let's say, the main user of the ecosystem, and citizens, crowdsourcing, bright guys that wants to go there. They are available, tools available, data available, and they have great ideas, and they know what to do with it. This is where we think it has to be discovery and opportunity-driven. This means you have this idea of brokerage. You arrive on the marketplace, as I said, you have data set, biology, Earth observation, weather, and you are someone with good ideas, and you say, okay, if I take this data, if I take this tool, maybe I need to get a scientist to help me, but then I can do a product or a service, and I'm quite sure I know who is going to pay for this service. So you build it on the fly. It has to be very dynamic, very highly dynamic, as I said. And you build your service. You sell it to the customer who is interested by the service, its value, its new service. And the price the customer is going to pay for this service will go all the way back down to the chain, to the value chain. So all those that have participated in the value chain will earn some money. So it's a win-win. Everybody participate is going to to retrieve some of its investment. So very highly dynamic interactions. Opportunity also because you will receive some questions. How can you help me for doing these kind of things? I mean, this is the things that will motivate you to say, okay, well, probably I can if I look at this, if I take this, if I take that. So this environment that will be very dynamic between scientists, between industry, between SMEs, between brokers, between customers, should create a lot of new ideas, eventually new science. One example that we are starting to work with is food. I think food is important. And food it's a problem at the level of the planet, okay, in terms of quantity and in terms of quality. So how we can deal with this, because if you start from the seed, let's think of the salad that is going to end up in your plate, but if you look at the seed, is it genetically modified? If yes, what is the impact? What is the soil in which it's growing? How much chemicals it has inside? How much humidity it gets? How much acid rain it may get? How much, all this at the start, okay, how this impact the plant that is going to end up in your plate? What is the impact on your health? So if we are able to trace all this data that come from completely different science, but able to make them for specific element that we want to trace, then you can really start to think, okay, we can get better food, we can know the impact on health, and we can eventually create better quality and quantity, and we are sure that it should help the population to finally have access to some. I mean, we've seen quite a lot of food. How would you say? Scandal about food everywhere in the world. So I think this is something pretty critical, and this is an example, but you can think about so many other examples of things that such an ecosystem would allow by putting together scientific data, tools, industry, politics, whoever is willing to tackle a global challenge and make it happen. And we've done it at small scales for some times, but I mean, it works. If everybody wants to do something, it works. So that's all what I wanted to tell you. Thank you.